Now we're going to do the present value of an annuity instead of a present value of a lump sum. So in the last tutorial, basically, I calculated what's the current value of $1 in the future. Now, in this case, we're going to do an annuity stream, which is the same amount of payment every period for a certain number of periods. So it could be monthly, could be annually, or whatever it is, but the concept is the same. Now, if the one key thing is that for an annuity, the numbers need to be the same every year. You can't have it changing every year. So if you said, I'm going to give you $100 a year for the next 5 years, that would be an annuity. Okay, so let's look at an example. So we're going to do a 5-year annuity, and I'm going to say that the amount of cash flow that you're going to get for each year is $100. So each year you receive $100, and what we're trying to calculate is what's the present value of that. Instead of getting that stream of cash flow payments, what would you be equally motivated to receive as just a lump sum amount right now? Okay, so the way you would calculate that, I guess the long way, is you could discount each one of these payments one at a time, the way we did with a lump sum. Year 1 payment, you discount it for 1 year. Year 2, you do it for with n equal to 2, and so on, and then you add them all up, and that would give you the right answer. But it obviously would take a fair bit of time, and if the annuity was something like 30 years, then that's less practical. The second way to do it is to use a present value of an annuity formula, which I'll do an example in a second. And then the third one is to use the present value tables. And there's present value tables for annuities as well, just like there was for the lump sum that we did last time. Okay, so I'm not going to do the long way. It's not complicated to do. It's just time consuming. So let's start with the present value of the annuity formula. And in this case, I'm going to assume the annuity is what's called an ordinary annuity. So the amount that you're receiving the money, or the time that you're receiving the money, is going to be at the end of the year. So when I say year 1, it's at the end of year 1, you get 100. At the end of year 2, you get 100, and so on. So the formula is the present value of that ordinary annuity is equal to the payment, which is $100, times that whole big bracket portion, 1 minus 1 over 1 plus I to the n divided by I. Okay, so I, again, actually before I get to I, it's important that I and n are for the same time period. So I is the inflation rate and n is the number of periods. So if you're using annual, then you use an annual rate, and n would be the number of years. If you're using monthly, then n would be the number of months, not the number of years, and I would be the inflation rate per month, not the inflation rate per year. So you would have to adjust that. So I'm going to keep it nice and simple and just say that it's years that we're looking at in our example. And the way it would work is, okay, so we've got $100 as the payment amount, and it's going to be 5 years. And the only thing I left out was inflation. So I'm going to say inflation is 3%, just like in the last example. So so if we plug that in, the present value is equal to the payment of 100 times 1 minus 1 over 1 plus 0.03, which is the inflation rate per year, times the number of years, which is, or not times, to the exponent of the number of years, which is 5, divided by the inflation rate, which is 0.03. And then that is pretty much it. So it's a bit longer formula, but you just solve for that. You'd get the present value of that annuity stream. And very similar to the last one, it's broken down into payment and the PV factor. So if I just multiply out what was in the bracket there, it works out to 4.579707, which works out to $457.97. Now, if you look at the right part of the formula, just as we did last time, it's going to give you the present value factor. So 4.579707 is the present value factor that you can use or calculate from the present value tables, just like we did last time. So there's present value tables for a lump sum and also for an annuity, and it's the exact same concept. So if you go to the 3% in the 5 years, you'll get the exact same PV factor, and you could do that instead of doing the formula for an ordinary annuity. And that might save you some time. It just depends if you have the present value tables available or not.